Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. As you all know, my name is Sir Joseph. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. In our previous classes, we discussed the various gas laws, Charles law, Boyle's law, Avogadro's law, Gay-Lussac's law, Graham's law of diffusion and effusion, and Dalton's law of partial pressure. We've stated all the laws, their various formulas, and how they can be used to tackle some questions. So in today's video, this is the first video that has to do with calculations in gas laws. So as soon as you subscribe, whenever I upload new videos, you'll be notified by YouTube. So that's one of the importance of what? Subscribing to a channel. So in today's video, we shall be looking at two questions on gas laws. The first one says, a gas occupies a volume of 500 milliliter at a pressure of 800 millimeter mercury. If the pressure is changed to 600 millimeter mercury, what will be the new volume of the gas? Now, in our previous slide, I said that Boyle's law shows the relationship between volume and what? Pressure. But Charles' law shows the relationship between volume and what? Temperature. So what do we have here? We have just volume and what? Pressure. So what does that tell you? We are using Boyle's law. So Boyle's law is given as what? P1V1 equals what? P2V2. The first thing you have to do as a student to be much more precise is to write out the formula, alright? You can as well as bringing out the parameters, then you slot in your parameters yourself. From the question, P1 is the initial pressure was given as what? That is the first pressure is known as the initial. So you have it to be what? 800 millimeter mercury, alright? That is what? P1. What about V1? V1 was given as what? 500 milliliter. So in this case, let me pause here, let me explain something. Before you start solving the question in chemistry, look at the options given. We are looking for the V2, which is the volume. If the volume is in liter, if the options, if the volume in the options are given in liter, you must convert from milliliter to liter. In doing that, what will you do? You divide by 1000. But if the options are in milliliter as given here, you need not convert. Just solve, you get your answer. But the most acceptable one is liter. So convert from milliliter to liter. So let's do that. So if I must convert from milliliter to liter, what will I do? I'll divide by 1000. So I'll just make my V1 to be what? 500 divided by what? 1000. I'll leave it because I don't want to solve in decimal. Then P2 from the question is what? 600 millimeter mercury. Was V2 given? No, it wasn't. Now you've brought out everything. So what do you do? Slot in your parameters then solve. P1 is what? 800. So I'll say 800 times V1 is what? 500 divided by what? 1000, right? So 500 divided by what? 1000. You see, so with this you can just cancel instead of using one decimal. Then P2 is what? 600. V2 isn't what? Given. Two zeros will go into two zeros. 10 go into what? 10. So 8 times 5 is what? 40. Then plus this last zero, that is what? 400. Then this times this is of course 600 V2. Right? So what do? You divide both sides by 600. This will go into this. Therefore, my V2 becomes, this will go into this. This will give me 0.667 liter. This we have solved in liter. But if the options were in milliliter, what did I say? You need not conserve. You do not what convert. But after getting it, you want to convert back to milliliter. What do? You multiply by 1,000. You multiply by 1,000. So this is the answer. V2 is what 0.667 liter. I believe that is what understood enough. So you solve. Let's solve question 2. Yeah, okay. A gas is initially at a pressure of 3 atmosphere. ATM stands for atmosphere. I told us that pressure has several units: Pascal, atmosphere, millimeter mercury, and torr. I told that 1 atmosphere is equals to 760 torr. 1 atmosphere is also equals 760 millimeter mercury. So they use atmosphere as what? Pressure. And the volume was given in liters, so we can just solve. So a gas is initially at a pressure of 3.0 atm and a volume of 2.0 liter. If the volume is decreased to 1.0 liter, what will be the new pressure of the gas? It is very, very simple. It is easy peasy. So from the first one we solved, you should be able to solve this without giving yourself much stress. Volume, pressure. So we are still using what? Boyle's law. So P1 from the question is 3, which is 3 atm. V1 from the question is 2 liter. P2 given from the question is okay, P2 wasn't given, so we are looking for P2. Then it means that V2 is what? 1 liter. 1 liter. So from what we have here, this one is even simpler than the first one I was solved. So P1 is what? 3 times V1 is not given, so times 1 liter. That is times 1 equals P2 isn't given, but what's it called now? V2 was given us. Okay. P1 is this 3 times V1 is 2, yes. P2 isn't given, then V2 was given as what? 1. So P2 times 1, what does that say? Is same thing as what? P2. It therefore means that P2 is equals 3 times 2 is what? 6 atmosphere. Alright. So this is the final answer. As you subscribe, more videos are yet to be uploaded on Boyle's law. I'm going to be taking each law bit by bit. Alright. We don't have to take everything once and for all. Let's take everything bit by bit. So at this point, we call it a day. Thanks for watching. Do have a wonderful day. Subscribe so that when I upload the new content, you'll be notified by YouTube. That reminds me, if you are not on my WhatsApp group, chat me on 091 6011 5375. Just send me a message on WhatsApp. I'll add it to my WhatsApp group. Alright. Do have a wonderful day.